These are the problems from the midterm. On the problem number 1, it says that we have a particular proton at a location which is moving with a certain velocity, and it says to find magnetic field at a different location at C, and the problem also says that the answer to be given in vector. We know that the relative distance of the location can be given by the observation location minus the source location, and here the source location is given as this 0 in this vector form, and the observed location is this. So subtracting the observed location minus source location, it comes to be this meter, and we have velocity v equals given meter per second. So now calculating the magnitude of the relative distance, which comes to be 0.0078 0.0078, and for the unit vector it comes out to be dividing our relative distance by this magnitude, which comes out to be this much. And we know that the magnetic field for a single charge can be given by this Biot-Savart law, which says B equals mu naught by 4 pi q v into r cap upon r square, and we know the value of mu naught by 4 pi to be 10 to the power minus 7, and q for the proton is 1.6 into 10 to the power minus 19 coulomb, and v is given, and r square we have already calculated it above, and r is the unit vector, and putting this all value we can calculate the value for v, which is, and the unit for v is Tesla. And the problem number 2 says we have given a quadrupole, and we have two different points A and B, and on the number A shows to show the electric field at this location A and B, and represent them by arrow, and we say that longer arrow means larger magnitude, and so it can be represented by in this form, and this one is longer because it is nearer than the other, and since as the distance further away, the electric field decreases, the magnitude of electric field decreases. And for the number B, it asks is VV minus VA positive, negative, or 0, and briefly explain that it can be is negative because the magnitude of A is much more larger than B, and so if we put those magnitude, then VV minus VA will give a negative value. And for problem number C, says to find what is VV minus VA. The change in V can be given by minus Ax delta I, because the x component is the only thing that survives. So we have already given the quadrupole equation in the solution sheet, which is the question sheet, which is minus h by 4 pi e naught over 1 upon x4, and for b minus a, this x can be represented by b4 minus a4, and so the delta v can be given by minus h by 4 pi e naught 1 by b4 minus a4. And now just to make sure above the units, if we put those units, it comes to be Newton per coulomb, and which is correct. And for number 3, glass cylinder is given with radius r and distance l, and it says to find the electric field due to charged cylinder at this location of the cylinder, and we have already given that E is equals to Q by A by 2 E naught 1 minus x by r, since x is less than r, and now taking the derivative dE equals dQ, which is and 2 pi r square. The pi r square is for the area cylinder, and E naught 1 minus a minus xr. Now we know that the dq by q can be given by pi r square by pi square by dx by l, and the dq can be equals q by l, and putting this dq in the previous equation, dE comes out to be this expression, and now taking the integration, which is from 0 to l, the E can be calculated. And it also says to support this answer that we got here by in three different ways. If we and for the number A, we can check this answer in terms of unit, which is to be correct, which is Newton per coulomb, and then number B, we can choose by if A will go to infinity, the field will go to 0, as it is not in the, then there will be no variables. And the number C, like the third way that we can check this answer is that the direction is wrong. given in this equation, in this answer, above answer. And for the number 4, it says a permanent dipole is at a distance d from center of a neutral spherical insulator. And for A, it says to show the approximate charge distribution. Since it's a neutral insulator, is neutral, so the total number of positive and negative charge inside the insulator is equal, as shown here. And when this insulator is replaced by a metal sphere, the problem asks to find the center of, draw an arrow to represent the electric field due to just the dipole, and label it ED. It can be represented by ED over here, and this can be further be simplified from this figure, where you can see minus and positive. Minus will be on this side and positive will be on this side, and so the adding the vector ED comes out to be on this direction. And for the C, it says to draw the charge distribution in and on the metal surface, which can be shown by this figure, charge distribution, as you can see here. And for number D, it says at center of metal sphere, draw an arrow to represent, it says to draw and represent by E pole, and which is shown over here. Since it is over this side, E pole is on this side. And finally, it says to find the net electric field, label it by ET. Since the net electric field is 0, since E pole plus E is are in opposite direction, and if they are minus x and plus x, it comes out to be 0.